do this. We're already talking compiler things. So this is Coffee Compiler Club. Here to talk about compilers and language runtimes and whether or not you can directly execute sea of nodes. I have other news. 3 days ago, we got a black kitten who's now sleeping behind me, so I'm not going to wake, and you can't see black on black anyhow. And my wife got COVID, so I've just been very busy. She's okay, but in the middle of it, getting all the right treatment. We'll see. Otherwise, I guess we'll dive in. We were just talking about, can you interpret sea of nodes directly? And Yasser was working on a sea of nodes representation and trying to decide if he was going to try to do an interpreter, and maybe has started. And if you want to say something, go for it now.
Yeah, so I guess for anybody who doesn't know, I'm working on a compiler backend library, and then the idea was, oh, can you interpret sea of nodes? Quentin in the CCC, I don't think he's not popped into one of these, but essentially he was asking about whether or not you could interpret it. And I was like, yeah, you probably can. Whether or not you'd want to is questionable. Although as like a debugging tool, it's kind of interesting. And so I'm writing an interpreter now, and I started yesterday, so I don't have much to work on, but I've got some implementation details that I think I've like worked it out in my head. At least it seems to make sense.
So what I worked out in grad school was I was going to have a sort of a Petri net for control flow. There'd be an active node, and that token would move from node to node just along the control flow edges. When it arrives at a node, I would forward flow the current types of things that were executed before into the new nodes in a breadth first search. And a classic breadth first search is just like, oh yeah, Alan did. We were practicing with Alan's camera angles. Yes, we were. The sort of classic breadth first search where you just have a list of things to do and a dividing line of things that haven't got all their inputs done yet. And the to-dos have all their inputs ready, and you do them, and then you take their users and migrate them across the line as you discover all the uses are done of other folks, and repeat until that's done. And that's a single large step. The couple of places that are a little weird, the fees don't propagate values forward. Like regular math propagates value forward. You get an add, as soon as both inputs have their most recent value, the add fires, gets its most recent value and pushes it forward into the next op. An if will stop execution. He needs his input, obviously, for the test. Fees stop execution because the region has to fire and tell you which input is going to get migrated out. And when you get done pushing the data values forward, the control token will then, that's a big step, and then the control token moves to the next spot. It's gated at an if. If it hits a region, all the fees wake up with data values that come from the corresponding input, and then you breadth first push all the values forward. So that was the semantics I worked out in grad school and hand did a couple programs. I don't know if
that doesn't sound too easy.
Breadth first is the only thing, and it's not hard. It's a dumbass loop. It's a work list. You pull a guy from a work list. You know his inputs are already done, so you just compute a value. Then he has a new value. You put it on the node. I would put him on the node, and then you take his outputs. They have one more value ready, and you visit them all. And most people you visit will only take one data input. They must be ready now. Some folks will take two. You put them on the one left to go pile. And the one left to go pile sits in the same work list as the zero left to go pile with just a dividing line in the work list. It says things to the right of the line, need one more input, things to the left of the line, have them all. And that's just an integer offset into the list.
It does not sound like something you can do in a week or two.
Oh, I could do it in an afternoon. That piece, I do breadth first search things. Well, it's just a breadth first search. Go write a breadth first search. If you haven't done a breadth first search, you should go write one as part of your self-education.
Well, like knowing the fees, you have to stop execution and do other things, and it sounds like just like a lot of things could go wrong.
There are some.
That part feels like the easier part. The annoying piece was like figuring out not like when the phi stop, but like what I ran into was like, okay, if a phi now introduces a new value, I have to now reevaluate some of the graph, but I don't want to reevaluate all of the graph every single time that you like jump.
It doesn't do that though. That's the trick.
Yeah, and that's what the breadth first search deals with.
Yes.
Yeah, and so like, yeah, that's the part. Yeah, it's the part that I'm currently writing.
Okay. So I have some breadth first search lying around in simple, which I might be able to show you. These are like,
Yeah.
I think it's in simple. These are not hard things to write, Levo. It's just like you read the algorithm
When I was
online
at
and then you
TA,
go
I feel
read
like the
actually how to
thing
implement
everyone
it.
tripped over for breadth first search was trying to use the stack as their stack rather than just making a work list, sticking things on a list.
Oh no, put them on a list.
Yeah, no, breadth first wasn't what I meant. I meant the stuff before that and around it.
You already have an abstract execution semantics for all your nodes because that's part of running a compiler. So add knows he can have a constant and a constant for the two sides, or one of them might be abstractly unknown. And then if he gets two constants, he does the math. And if one of them's 0, he can do some math. And if they're neither one's known, he just gives you an abstract int. And that's all semantics that are thrown in already. And you have them done for all nodes. So that's how your optimizer works. Having done that, that's good enough for an interpreter as well, because it's all hard constants. I take my evaluator virtual call on every node. His inputs are guaranteed to be constants. I evaluate, I get a guaranteed constant out. Life goes on. So that piece is straight up. The weird one is breadth first for your inputs before your outputs, and then fees stop. They don't progress until their region fires at the next major step. So, do you want to show something, Yasser, or you want to wait till next week?
Yeah, I think I'm gonna have to wait till next week.
Bummer. Okay. All right.
So I wanted to ask, like, so this execution semantics is like it published? Is it in your thesis or something? Or I mean, I just
yeah, right. It might make a paragraph or two in my thesis. It's like I was sorting out what Sea of Nodes looked like as an IR, and could I do stuff here? And it seemed like it was SSA on steroids and had all the right things. And so I practiced it a couple times, and I sat down with a grad student buddy, and we worked through some simple programs and decided it was sound and did the right things. It may have made a paragraph or two in my thesis.
Yeah, because I'm looking at your thesis. There's a section, you know, 8.4.1, a model.
I'd have to pull it up, dude. That was 40 years ago.
And it has like, it says it uses a PetriNet model for the control subgraph and like a data flow thing.
Yeah, that's it.
All right.
All right, so you got the paragraph. That was just what I said.
Okay. All right.
You know, not a whole lot to it.
So if it was 40 years ago, you're being consistent. PetriNet 40 years ago, PetriNet now, so.
Yes, yes. Well, the semantics didn't change. I think it's just actually, it's close to 40. It's not 40. 35. Fine.
So now I'm curious, what would you say you think about compilers now that you most disagree with what you thought 40 years ago?
Oh, what I most disagree with?
Yeah.
Oh,
what does thesis writing Cliff have wrong that you'd be like,
right.
no, that was totally wrong track?
Yeah. It's the languages have a giant thing wrong. Everyone wants to type option instead of just fucking using a null, but it has exactly the same semantics. And after you get the zero cost Rust model, which a lot of folks do, it has the same cost too. Why do you have to have all
40 years
typing?
ago, Cliff probably believed that too.
Yeah. Except 40 years ago, it wasn't easy to unwind the option. Now we've sorted out how to unwind it well. So that was my major complaint. The other one is, you know, people should have grabbed Sea of Nodes. I pushed it hard long time ago, and very few people picked it up. When they picked it up, they loved it. Most folks didn't bother to pick it up. And then HotSpot arose, and like, you know, 10 years ago, 20 years ago, I was counting, oh, C2 is running 10,000 times when you start at JVM on roughly 1 billion servers daily. I'm probably averaging somewhere above 1 trillion compiles a day, and no one knows how this fucking compiler works. This is like madness. Like, you go to these academic conferences and they talk about compilers, and I'm looking at them like, C2 who did that 20 years ago, and it does it in you know, constant time, and it's like fucking, you know, free, and why are you here? You know, what reviewer let you slide this in as not just completely prior work and a complete waste of time? So that went on for a long time. Kind of I'm seeing a resurgence of Sea of Nodes now, you know, 30 years later. fine, but that sounds good. But everyone's been using, you look at LLVM as the canonical poster child of the wrong way to do it. It's what we done long time ago, and Sea of Nodes in my head.
But LLVM has been available as a library in a way.
Yes,
Nodes was not as approachable as a library.
That's true. And I thought somebody would have grabbed long ago Sea of Nodes and made a library. And one of my goals for AA is to do exactly that.
The weird thing is I always hear people saying that LLVM is the best way to do it, but also not very good for one reason or another.
Oh, yeah. I looked at LLVM.
But it's best for tooling reasons, not technique reasons.
I just know that I didn't end up liking it.
I watched LLVM in Julia, where Julia was trying to do runtime code generation, and it was miserable. It was not only slow, it generated crappy code because it had no clue how to do cross compilation unit optimizations. And, that's just, C2 is just full of that shit.
I'm going to blow your mind, Cliff. You said LLVM is slow?
Yes.
It's faster than Go.
Than Go's compiler with optimizing turned on.
Oh, no, debug builds.
Okay, fine. Yes, that I can believe. C has had fast debug builds for a long time, witness TCC, where they were optimized to the limit of how fast can I convert C source to something I can execute and maybe have debug hooks. Fine. That's a straight up bandwidth, one pass in, one pass out, read it and write it. How fast can you shove bytes around?
That's the funny thing. You'd think it would be that debug builds are just, let's go one pass all the way through. No. I was looking through it. I was explaining this to somebody yesterday, but essentially, I think it's around 20-ish passes that have to run at minimum for LLVM, because there's a bunch that are machine IR that deal with like the register allocator and a bunch of other like little legalization things. And then there's a bunch of passes in the IR to legalize it, because sometimes you can construct things in the IR that are like not machine code friendly, and so they get like folded out into like bigger patterns.
Right. I'm just saying there exists a C compiler, let's call it TCC.
Yeah.
That can do this as fast as I think it's doing in one pass. But LLVM
TCC is still one pass.
Yes, has done.
But honestly, though, like considering it's one pass, I think TCC is still too slow. But that's also not really TCC's fault. I mean, it's also C's fault, because like there are some things, like I don't know, like there's some things that are hard to parse.
What is that? Is you actually slow? It's not just memory bandwidth costs. If I hand you a gigabyte of C source code in a file and you're supposed to TCC it, aren't you just going to be memory bandwidth bound?
That should be the case in practice, but like just looking at the numbers, it's odd. I mean, I like it. I've seen like benchmarks that show TCC compiling C at a rate of like 500K lines of code per second per core, which feels still like way too slow.
No, those benchmarks are completely wrong. I managed to get more than 2 million in one process.
Switch
TCC?
Lines of code to bytes.
Yeah, TCC.
Go to bytes here, because this is going to be the bandwidth you're measuring.
Right. Yeah, I didn't look at bytes. That's a good one.
I think the bytes was like 20 megs, but it was also, I also just did with the array test. It's just you pass in an array, you assign it a constant value,
right,
with the constant index, and like that's it.
So that
By
one,
you're including the link time, right? Oh, sorry.
Yeah.
I'm telling you that benchmark is very weak. It only
it is, but it's just to get an idea.
Okay, like I would expect that would be an upper bound. You're not going to get any faster unless there's a screw up going on in bandwidth or something. Because you're only going one pass through the optimizer, all branches will predict, all things will predict branches correctly, because you're only going to one pattern that you're looking at. All lines are short, and so on and so forth.
I can probably compile it during this call, but from memory, SQLite was also less than 1 second with TCC.
Okay, that would be a better test for sure, especially if you could.
I'm reminded of a story that I'm going to get slightly wrong, because it was from the Google compiler team. But they used to talk about, they had these projects that were 1 million lines of C and C++, roughly 30-ish megabytes of code. And LLVM and GCC would read off of the disk 8 gigabytes of data, because there were all these includes, and it would read the same header file, and it would read the same header
sounds-
file again, and it would if def ignore it, but it would have to read it over
That
and
sounds
over and
reasonable.
over again. And
Yeah.
it's like
Isn't
once
there-
you're reading 8 gigs of disk
mean,
into memory for 32 megs of code, you lose.
I
How
work
else would you do it?
C compiler setups, you know, that cached and whatever, and they would have pound includes memoized internally. They would read them once, and when it came to read it again, they do some hashy like check on the thing on disk and declare victory and say, I've got that already. That was a known speed optimization for repeatedly rereading pound includes. And in 20, 30 years ago, I think HotSpot was doing that shit.
Right.
Yeah.
but
So one of the big ones that comes up, which is actually like, I'm not going to defend LLVM or GCC because I actually argue that we can write compilers better this way, which is that because we're doing it as separate processes, we can't do resource management across like different different like compilation units. So you can't cache things like includes across them. That's a really annoying like stupid loss that we get.
You can, and that's what I'm talking about.
So
Yeah. So
Cliff, you're missing
LLVM
something.
and GCC will both
Okay,
like
wait, let
do
Yasser
caching.
finish, Cameron. Yasser, go.
Yeah, so LLVM and GCC will both do caching within like one translation unit within one process.
One translation.
What I'm arguing for is actually it would be better if they compiled if you have one process and then on different threads you do all of the like translation units,
Right.
and then from there you can do resource management threads and stuff like that a lot more like effectively.
Yeah, here's memcached coming around. Yeah. Yes, yeah, I entirely agree, and I want to claim that I was using that when I was building HotSpot 20 years ago. Something similar to what you just said, but
Yeah.
it wasn't the normal setup. You had to do a little screwing around, make it happen. Okay, Cameron.
Yeah, I mean the problem is that you're used to writing C headers a certain way, which is the same way most rational people write them, which is the first thing you say is pound if and def.
Right. Yes.
My header underscore
yeah,
whatever.
yeah.
And then the next line is pound define, that same thing, and at the end of
Yes.
it is a pound end if with a comment after it with the name, right?
Yep.
And in that case, you can actually cache pretty
Yes.
aggressively.
Yes.
Other than caching the source code, though, C headers can do things
Yes.
such that you have to reevaluate them over and over at
Yes.
each.
And HotSpot does those as well.
Yeah, so it can
But
be
they weren't
pretty
part
nasty.
of the. I'm setting you up for caching behaviors that we worked hard to make our builds go fast with. But
Right. So you can cache the text, you just can't cache the side effects.
We were able, I swear we were able to cache the symbol table. There was some magic flags we were setting up to some compiler where we could tell it to cache the fucking symbol tables, and those would be valid, and he would do some hash check and declaim them valid and not reparse the symbol tables.
Oh, like precompiled headers and stuff?
Yeah, like a precompiled header. There was something going on there where we had a scenario that we were using on a daily basis. And yes, we did all the right things with headers, so semantically legal. I think the caching guy wouldn't pay attention to those. He would just cheat at you. But if you did the right headers, and it didn't matter whether you cheated or you didn't, you got the same answer.
Yeah. Anyway, I was just agreeing with Yasser that some of the fault lays on the infinite flexibility of C. And
yeah, it's a macro processor, so therefore it just does what.
And then of course C++ fixes. Oh wait, no. C++ makes it worse. Sorry.
Oh, wait. You ever thought C++ did anything that made it better?
I told you I have a love-hate relationship with that thing.
And Aaron, what
It's still like classes.
It's fun playing with bombs.
Yes.
I want to see with classes. Classes are nice.
A single inheritance classes, yeah. And I made a lot of mileage out of custom new and delete, which
templates are simple. What could go wrong?
Yeah.
I remember the first time I learned about templates. People were like telling me, like university students were telling me, this is great. So you gotta like learn how to do this. You gotta use them. I'm like, why would I ever want that? And then I end up liking them, only to realize, no, I was right the first time. I don't want that.
So we were writing HotSpot in the era where C++ was around. We wanted to use it, but it was very unstable from target to target. And so you had to use the minimal subset of C++ that was valid across all your compilation targets. Like Sun was trying to be portable. You're competing against Microsoft. So write once, run anywhere. That meant it had to build everywhere. So portable C++, limits on the amount of things you do with templates, fine. We use square bracket array lookup templates. It's probably the only valid use. And I don't know these days, but back then it's like the only thing we let them go. But somewhere in there, somebody handed out the version of templates that gave you prime numbers, sequentially increasing prime numbers for error messages from the compiler. And that's when I knew that C++ templates were, you know, work of the devil. It was done.
Yeah. So about portability, let's say you write your app, it compiles fine for every OS, but one of the OSs it has a bad implementation of some function. Like it's correct, it's just it doesn't do what you expect. Does it count as bug, or is that like not portable? Like what would you call it?
Oh, we would wrap that in a portability layer.
Yeah, because I
Buried in
remember hearing.
HotSpot, there's you know, in Java, you call it source main Java. You get down there, there is a regular VM source, class loading, C2, GC. There is per OS specific directory. There's per CPU specific directory. And then there is an OS CPU specific directory. And in there is all the wrappers that work around the behavior. Now, is it buggy? I don't care. We have to make this run. So we changed the behavior with the wrapper to do what we needed to do, and life went on.
So at someone said that at Google, somebody was depending on the order of a hash map.
Oh,
So that's why it would work on some OSs and not on other, or versions and not on others. So is that a bug, or is that portability issues? I have no idea.
So way back in the day, my
Dumb
first
as shit.
first coding job, I had to do a PostScript implementation. PostScript had a font cache. It turned out that there were apps that depended on the order of evaluation of fonts in the font cache. So we reverse engineered Adobe's hash function so we could match their hash visitation order. So that sucked. And then there was a bunch of things in the JVM that, you know, people depended upon the order of classes or subclasses you got when you asked for, give me all your subclasses. And people in JVM land thought that was a bad idea, me included. And so we changed the JVM to say, not only is it order not guaranteed, but we will change it every time we launch the JVM. We pick a random seed up, we'll screw with the order based on the random seed to stop.
Yeah, thanks for that. That was fun encountering that.
You did encounter it. Excellent.
It's not that I cared about the order, but it's like, why is so I was working at, well, I won't say the company's name. We dynamically generated mbeans, I think, based on this, and the order that things would show up in JConsole ended up being dependent on this. And so we had to just like randomize order of the UI, and it was like, okay, who did this? Why is it intentionally randomized? Let me sort things.
Right, exactly.
So now I know who.
Got more robust. And now the JVM is allowed to change hash functions if they discover there's a better one.
No, it was stupid to depend on it. I was just surprised. Like, I didn't care the order in the end. Right. I just cared that it looked different. The UI looked different every time I went in.
That's like rough. That's so bizarre. Like the UI changes. Adrian, I put in numbers in the Google Docs like a couple of minutes ago, so it does compile that fast.
I haven't looked at Google Docs here. No. Yes. Combining it now. Oh, there's my thesis. Oh, here's SQL. This is what your numbers for TCC SQLite?
Yeah, so I just grab a copy from just now.
125 milliseconds to do however much, 227K? That doesn't seem.
How big is this? I mean, like most of the repo is, I think, tests. So like how many lines of code is in the C file?
Bytes of code.
Oh, bytes. Yeah, sure. Of course. Sorry.
But he did a word count right above you. You're right there.
The bytes are on the page.
I see 9 megabytes.
Ah, okay, now I see it. My bad. Sorry. Yeah, thanks.
10 megabytes. Now, I think those numbers are consistent with a well done read it once, write it once. You could imagine going a little faster, but not hugely. Is this after you repeat a few times, get your OS caching, Lilo?
Yeah, well, I have it in my temp directory. Most of the time it's 128, but that's because I opened up more windows. Yeah, so that probably had more to do with it than
right. No, it wasn't coming off of your grindy rusty metal disk drive. That was a good question. Yeah, that's fine. Also, the compiler has to load up and other things load up, and so it's all good. So
One of the weird lessons I learned when writing a C compiler was, first of all, just how many files end up actually getting included and how much cost that comes up to. But the other interesting bit was actually realizing how little of that cost is actually the file I/O.
Yes.
Like, I was told originally, oh, the issue is you're loading 300 files. That's going to be a file I/O cost. No. The issue is that at the end, you've included, let's say 30 includes. Those all include some 5, 10. You end up with 1 million tokens at the end. And from there, that's where the cost comes from.
Okay. Yeah.
The
Yeah.
funny
Keep-
thing for me
keep
is
kids
the
with your
tokens are
flash
so
drives.
cheap.
Yeah.
You have to have a decent hash function and a large hash table. A hash table has to be sensible.
Yeah. I like go back and forth. I have a bunch of like random hash maps in my code base because like there's like a really generic one, but it's like really shitty because writing generic stuff in C is really annoying.
Yeah.
And that one just runs really slow, but it's convenient. So when I need to like pull out a hash map, it like works.
Right.
Yeah.
Java happily made one that was working for everybody all the time and also slow for everybody. Well, slow if you did primitives. If you did references, it was par for the course.
I need to write a proper hash map. It's just I don't want to use templates and
Don't use templates. Write a proper hash map with void star polymorphism. C2 uses void star polymorphism hash maps.
Yeah. So I had a specific implementation for when you had a 64-bit key and a 32-bit number, because for whatever reason, a lot of my numbers happen to be 32 bits, and since I'm 16, but I got to make another copy for 64-bit numbers and another one for values that are like binary, like
Why do you want to
you
avoid
don't-
templates other than the horrific compiler errors?
Yeah.
Specifically because like actually let me just think about my answer because
because I hate templates. I get it, but still fine.
It's more like because I know my language is not going to support templates, so, and I kind of want to import it, and yeah, just templates are just really annoying sometimes. Like you don't actually know the cost.
If you're writing a hash table in Boolean, you have some choices to make about whether or not you're using primitives or references for keys and values. And who cares? Like who's the consumer of these hash tables? So I would go do a concrete implementation for a use case where you need a hash table. Are you writing Boolean in Boolean? Go write a hash table for your symbol table lookup. And that'll be strings on one side and whatever else canonical type data on the other, refs on refs.
Like I'm fine with a declaration using a template. It's just I don't want any template magic happening with like converting the key into like a hash, because those can get really strange sometimes depending on overloading and all that.
Building HotSpot, we use square bracket array vector lookups. Very limited use of templates, and the only thing we did out of the templates was the body of the array was elements were either ints or bytes or bools or whatever they're going to be.
Okay. I don't know if this is just news to me, but integers, like sequential integers, are actually really bad for hash tables. Like if you're not using a hashing function, just like using sequential numbers as a hash function is a really bad idea.
You have to
Also,
use
this feels sort of like this feels like the time to shill fib hash. You basically just like multiply by a big number and then you shift down, and that's it. And then that big number is some fib number if I remember correctly, and that's it. Let me go send that in chat actually.
Yeah, maybe it's just news to me, but the reason why is because you always think it's sequential until it's not, and then you have a bunch of buckets that are not hit, and your speed just goes away.
Right, everyone hits the same bucket. Like if you're doing a bucket hash instead of an open hash, then you've got the modulo function takes everyone who's sequential and maps them to the same bucket, and they all pile in on you. If you go to a power of 2 open hash, you get the similar effect in a different direction. So when I do my non-blocking hash map, I have a hash spreader that takes whatever bad hash the user gave me, pushes it through something just like what Yasser wrote, and I have a slight variation that I picked up from Doug Lee. it does more bit shuffling to shove low bits high and high bits low. But yeah, do anything.
Right now, my two favorite hashes are xxHash and Murmur3.
Definitely for a spreader, I definitely want a really cheap function. I don't know, is Murmur that cheap?
So if you're doing murmur on really small stuff, you probably want to like specialize it, and in which case it is pretty cheap.
Okay, but like what you just showed, that's like
I just use
4
SHA
o'clock latency,
512. It's pretty
1
quick.
o'clock. Sorry, Cameron?
SHA 512.
Not for my hash function. Thank you, sir. Your advice has been acknowledged.
It's a very good hash function, I will tell you that. But no, don't use it for performance.
xxHash has intrinsics and is really fast. But
Go
Murmur,
tell us what the intrinsics do.
I don't remember the source code. I tried it out. I looked at it very briefly, but I don't actually remember if I actually looked at the entire implementation.
I have a friend who like has a copy that's pretty short, and I don't think it has any intrinsics in it, so I'm gonna send that one. Actually, should I be putting these links in the Google Doc?
Yes, yes. So future viewers have a chance.
Yeah. All right.
So I was diagnosing a run my tests in parallel harness thing and got a 10x speed up by fixing my broken hash function. I did not realize my hash function was so bad in the AA types, and fixing the hash function, like I said, give me a 10x speed up on my testing. It was a giant number.
Was the input like sequential numbers?
It's like I had, not quite, but it's close enough. It was like types are all want to be interned, and so a type is like I'm a bare int, or I'm an int range, or I'm a high or low int, or I'm a float with the same story, or I'm a struct with fields, or whatever. And a lot of these things, I started out by saying, oh, the hash will be plus or minus 1 if you're invariant fields or read-only fields, and plus or minus 1 if you're this, and plus or minus 1 if you're that. And you XOR them all together, a bunch of plus or minus 1s, you get an answer that's 1. And there were some 1024s and some 255s and whatever thrown around, but I had some hash numbers were commonly attributed to items I was interning millions of times a second. And they all came to the same 20 guys, 20 common guys hit in the same bucket. The 20 common guys were being interned a million times a second. So I would load up a struct with fields, hash it, look in the hash table, walk my 10 things or my 20 things in the table, find the hit, get back and say, I got it interned already, done, carry on. Except that I was walking 20 things in a row instead of doing a hit on the first one.
I got a better answer for Mark about why no templates. It's because I'm going to implement a specialized version for each key size or value size as well. So if I'm going to specialize like 5 different versions, there's no point of using a template.
Isn't that exactly what templates are for?
Yeah, but I don't want the
No,
same
but he's saying different logic.
Oh, different logic.
Yeah.
Templates let you do that too. I mean, I hear you. I hate templates, except, I'd rather use them than copy paste.
It does the same thing, except the error messages are just much worse.
Yeah. But, when you have to fix a bug, well, I guess you'll have more bugs to fix with templates, but when you have to fix it, it's nice to fix it in one place. But, I hear you. The error messages are horrific. I did have a question on your hashing thing, though. Like, why do sequential integers result in bad hashes? I would think that's basically an ideal hash.
No, I've hit it before.
It's just because you just get gaps. Like you always get gaps for one reason or another.
They solidly fill in a bunch of things in a row. And then if for whatever reason you get somebody who hits in the middle of there, but it's not one of the integers you put first, he has to walk in the reprobe the whole set of things in a row again until he finds
yes, for an open addressing hash. Yeah.
Right. Well, if I hit a modulo
I'm with you. That makes sense.
Okay. Fine. I use I said this before, some burble.net guy has a nice hash function I picked up, and it did me well, and it was a little more complicated than Yasser's, but it did a nice bit shuffle and does all the right things. All right, must be time for a new topic.
I'm
Oh.
pretty sure I heard Adrian say he wanted to demo something, but I don't know if he meant
Oh,
like
yeah.
today.
Yeah, I was exploring this wait, first of all, I need to say this SQLite. I mean, like this SQLite 3.c file. First of all, it's like this ML it's merged, like
Yeah.
it's prepared, right? So it's already composed in such a way that it's amenable for fast compilation. So like this is one thing, and the second thing, there's a lot of comments in there. I think at least 20% of this file is comments. So I just want to clarify.
I think that's fair game. I would like to think that my code has 20% comments.
Right, but like then, you know, the megabytes per second thing, like also like comments are very dense byte-wise. So yeah.
No, but I think that's fair. That's you count bytes. If you're doing a debug build, this is about how fast you can shove shit in and out. If you can't parse and nom comments fast, live script or regex on your comments, it's like bad news. Fine.
All right, yeah, I just wanted to get that out at least.
Yeah.
But yeah, anyways, like yeah, sorry.
So C-Lock or it says that there's 180,000 lines of code, and then the rest are comments.
All right. So a bit more than 20%. Okay.
I'm curious on how many like pre-processed lines there are.
Ah, good point. Yeah, I didn't think about that. Yeah. Anyways, so basically, I was looking at this ispc Intel compiler, so like for implicit SIMD programming, and I mean, I'll probably talk more about this like next time after I finish.
Actually, I misspoke. It looks like it might be 81,000 lines of code, and then the rest are blank lines and then comments. But yeah, it's close enough to 100,000.
Your word count differs. You posted a word count that gives lines. All right, yeah, sir. Why don't you not yeah, sir. Adrian, why don't you go ahead and go? I have to look up your ispc while
I posted it. So it's interesting. Basically, it's very similar to a C-like language. There's some minor like differences. For instance, they have like a few more loop types, like for each and for each active and whatever. And the general idea is a bit similar to what you would write in OpenCL, but basically you have one function and it looks like a sequential program. And the thing is, this program is going to be executed by each SIMD lane. So you get this like parallelism, and you want to write these functions in a way that you're not like creating like divergent branches or anything like that. And the compiler will take care of like masking off certain paths. So like it has these execution masks and everything. So it tries to basically vectorize things reliably. And also it gives you like some guarantees. For instance, it has this distinction between uniform and varying. I believe in OpenCL, there's also something like a uniform values.
I really would like to see some source code if you can show.
Yeah, sure. I can share some.
I don't know. I'm not familiar with the language.
Yeah.
You want the screen share?
Yes. You know what? I'll come back to this. Someone else can like start a new topic, and yeah, I just need to clean up my desktop a bit.
Sure. All right. New topic.
I have a sort of related question to the topic because Lego mentioned he doesn't like templates and it's not going to implement them for Boolean. I'm kind of curious what your approach for generics there is going to be. Are you not going to bother with them at all? Or yeah, basically what are you going to do there?
Yeah, that's the one thing I'm unsure about in Boolean. I would like to think that most of the critical stuff would have to be built in so I can make like lifetimes and ownership and all that easier to manage. but I have no idea how I would allow someone to make their own hash map. So that's the one thing that I'm actually not sure about. Everything else, I have a really good idea, but just allowing users to make their own containers without generics, I'm not sure. Maybe I have to implement templates just for that, but I'd rather not if I can help it.
Containers are synonymous for generics. How can you have the one without the other?
Hey, if you cast everything to void,
Java did it for a while.
Okay, that's one way. But you essentially throw the types you know you need them. So
right. So what Go, for example, did there is before they introduced generics a while back, they actually had generics for like slices and maps, but they were like, no, you can't use that. Only the blessed Go compiler code can use it. And that's kind of one way. I think if you do maps and arrays in a special setup, you can kind of get away with it because you can kind of squeeze most data structures into a hash map or an array.
And they got around nicely with structural typing.
Yeah, but I am curious there, Liva, is the concern more the sort of compiler side of things, or the kind of inevitable, how do you call it, type soup they end up with, where people say, hey, I don't want generics, but I also want hierarchy in the type and reify this and like this. The complexity from the user side.
Halfway mumble their way forward into generics, but not quite.
So this is what I did. So I had templates briefly for my compiler. I had it in my actual compiler and prototype, and it just made things look like, or it made things end up like C++ templates, where it's like basically Turing complete. And I said, no, I just don't want this. And then I tried implementing generics, and at some point I realized that there's no good way to have things inline and optimized, which might be important to a couple of people. So I scrapped that. Like with a JIT, you can optimize it if you know it's hot, but I don't know what's hot, and it would have to break some rules that I assumed would be. It would have to change some of my assumptions, so I end up not liking it. And one thing I was thinking about is since I had C++ code be able to be inline into Boolean, I was thinking maybe someone could just write a class and then implement it with FFI. But I also would want to reduce as much FFI as possible, just because Cliff horrified me about some stories about people using Java, breaking Java because they held on to pointers. So I'm not 100% sure on my FFI story as well. I'm gonna have it. It's just I'm really not sure what I'm gonna do with it.
Yeah, but do you plan to represent abstract types in Boolean? So, or you will offload that to C++, which will become...
The idea is I could offload it to C++, but I don't actually know until I get there. So I have to implement some memory safety to know what my restrictions are.
Yeah, that sounds fair. Sorry, go ahead, Aaron.
I don't know if this is a useful framing. Usually when I think about generics and templates, I think of it as, look, I want to do a small talk like thing. I have one type, it has an API, I'm only calling the things that are on that API. And I have two implementations that have the same API. They may or may not have the same API, it should still compile. And now when I call it with the first type, either the compiler does something generic or it specializes the function for type A, and either it does something generic or it specializes it for type B. And I feel like the whole game is I just want to write code, but not specify the type of one of my arguments and say something will be passed in. If my function matches the API, great. If my function doesn't match the API, then that's not valid code. And I don't want to have to think about the API.
So that's
I think
the thing
Python
with,
accomplished this
generics.
reasonably well. JavaScript accomplished this reasonably well. Smalltalk accomplished this reasonably well. But they all did it by having very generic types.
but that's the thing about in Boolean, because if I get the if you specify the interface and you get the type, you don't actually know what the type is until runtime. So you can't really inline it unless you inline everything. But then you also have to inline libraries that you have to recompile for every library that you're adding, which is like fine. But
what do you mean the generic type is not known until runtime? Do you mean to represent the generic types in the libraries? So the code...
basically I can't inline it because I don't know which implementation it's going to use, because it's going to be accessing it through like a pointer.
It's special. You got specialized versions.
So I heard
catching a specialized type.
So I heard interface here. Do you mean that you have a type where you do something like, some user structure, you say, cast that to a two-string interface? Or is it more
when I say interface, I usually think of C# and Java-like interfaces where it just specifies the signature of all the functions.
Yeah, because so the reason I'm asking, because they're sort of make sure, I guess, we're not discussing like two separate subjects.
Yeah.
Because it's true in the sense that if you let's say you basically use dynamic dispatch, where let's call it interface dispatch. So I guess technically it doesn't have to be dynamic dispatch, but the point is you take your data, whatever it originally was, and you turn it into something more abstract, like a pointer to something, and your compiler only knows, this is typed as the two-string interface, for example. The other version is where you have generics, and you basically say, hey, this function takes whatever, as long as whatever type that is implements the two-string interface, for example.
That's a nice point. Yeah.
And in that first case, yes, you lose type info at the compiler because you end up with this, let's say, a function where its argument is a two-string interface. Yeah, and that could be any one of 2 million types. In the case of generics, though, that isn't necessarily the case. That you would. Sorry, hold on one sec.
I can tell you the Java version of this and how it plays out in a lot of detail.
Well, the Java could just JIT it, and I don't plan on having a JIT. So, and I want to be competitive with C and speed.
This is not related to the JITting. If I get an interface type, I lose the base class. And I don't know what the base class is, and I must make an interface style call. That has a particular cost to it. In particular, as York points out, many people implement the interface call, the two-string call. On the other hand, if you have a generic, I do get the base class, and you're one of the subchildren of the guy, and I don't know which one, but it can be the case that of the subchildren, only one or two implement the particular call in question. I don't get the entire universe. I get the slice limited to the child of the base class that was part of the generic. And that's often enough to let me optimize better how the call goes. The other one is that because everyone has a known base class, they put the two-string and the vtable in the same spot, I can do a vtable call instead of an interface call in the worst case. So the worst case scenario is low jump register. It's not happy, but it's not terrible. Whereas the worst case interface on something like two-string is pretty brutal.
Or tiny cache recall. Is it type 1? Is it type 2? Is it other?
Yes, that's C2 saying if I have only a handful of implementations from the base class, you'll get an instance subtree for the hot guys. Even if I didn't have any profile data, I'm all compiling ahead of time, I might do an instance subtree if there's just a handful of guys. And the V call is still faster than the interface call.
Maybe this will explain my problem easily, but I want my code to be as performant as C. Like I want the binaries to produce to be as fast as if you were writing C.
Right.
If someone hands my function like a type, like that follows like an interface, GCC and LLVM is not going to optimize. Like if I have the interface, it's not going to go back and figure out if it's only ever passed one specific type and optimize for that. Like the GCC and LLVM will not do that.
Right.
So if I can't trust the optimizer to optimize the entire function away, then like it's just gonna have either two copies, or it's just not gonna be as optimal as if you were to use templates where it will go through the entire thing.
Okay, so I think you're conflating a couple different things here. You mentioned some code that would be slow for everybody, and it doesn't matter that it's GCC or LLVM. It matters if it's I have runtime profiles or I don't. You can have runtime profiles in LLVM. That's a different topic. If you have no profile data and you have a dynamic type, then whatever you're going to get out of GCC or LLVM has a certain cost model to it because they have to make these conservative assumptions. The other assumption that you went with is open world versus closed world. If I am compiling everything at once in an LLVM and I know that I have the entire program, whole program compilation, then I can in fact count subchildren and know I have however many implementations. If I'm compiling a .o file, I have an open world problem and I don't know how many implementations will show up when I get linked.
I don't believe that LLVM will use that information even though it has it, but I did not try profile guided optimization for that test specifically.
Okay, let me
I
break
just
out.
know that I just know that program guided optimization doesn't work for my compiler. It makes it slower.
LLVM does have the virtualization pass, and I believe it may also be making use of PGO. So I would try the virtualization pass. It maybe some versions of that pass are disabled by default. You have to go to the client manual and look for the compilation flags and just grep for the virtualize. There is several of them, so you might have to enable them all. And if you are not generating general C++, then don't worry about those disablements because they are for things like people changing the value of this pointer inside member functions, which makes the virtualization illegal right now. But if you don't do anything like this, then you can just enable this.
Maybe I'll get you a reproducible. And,
I got burned by that one.
Confirm.
Yeah,
it's just that I don't know what the optimizer is going to do, so it's just easier not to rely on it. And I might write my own one day, so
you'll learn what they do. Then, if you write your own, then you can trust or not trust a little better. But
yeah, I was gonna say here that it sounds a bit like a case for writing your own passes. Like it's the same approach I'm taking, where it's kind of redundant in the sense that if you use LLVM and then you write your own optimization passes on top, unless those, of course, are highly specific to your language, like certain things LLVM just won't understand as well. But I'm going a step further there, where basically my plan is not to use any LLVM optimizations at all. And write them myself, and that is mainly because I intend to replace LLVM at some point. I'm kind of secretly hoping that crane lift, for example, will become more stable at some point.
Yasser's got you covered.
Or somebody else is like, fuck it, I'll write my own. But basically, I'm hoping for somebody else to do that work, right? And so I don't want to basically build a compiler pipeline where its performance hinges on this black box that I intend to replace at some point.
Right. Yeah.
Yeah, exactly.
And I did recently sort of begrudgingly make a change there where somebody had this benchmark suite of, I think it parsed some JSON file and did some deeply nested loopy thing, whatever. It wasn't the best, but I compared a whole bunch of languages and they're like, hey, I have a thing for Inco. Can you take a look at it, make sure it's sane? And I think I managed to I don't know the opposite of underperform Python by like a factor of 10, which was quite an achievement. I think it took like 10 seconds, whereas Python took like 1 second. But that was one because no LLVM optimizations. So I did begrudgingly add a change there where my compiler had a aggressive option, which is meant for these sort of future optimizations where it's like, I don't care how long it takes, just, optimize the hell out of it. And that's where I basically made the change, like, hey, if that flag is set, enable, I think, the equivalent of O2. That sort of highlights why I didn't want to do that, because then your compile times go from like 2 seconds to 10. And it, quote unquote, only made it, I think, 4 or 5 times faster. And then I think the other cost is mainly function calls, because I don't do inlining at all right now. And yeah, that adds up, especially if you use function calls for integer addition, arithmetic in general. 10 plus 20 is a function call. Do that a billion times in a loop, yes, it starts to add up. My point there, where I was going, is that this issue of devirtualization is a challenge for my language as well, because my generics approach uses dynamic dispatch by default rather than monomorphization. And that's mainly to keep compile times fast, but also because in my language, most types are addressed through pointers. And so at least at the memory level, if I have, say, an array of user objects and an array of integers, memory-wise, they have the same representation. Because in my language, integers are always 64 bits. And I don't support 32 bits. So pointers and ints, for example, have the same memory representation. And then generating essentially two different structural layouts is redundant, right? So that's where devirtualization is going to be important. That's also why I decided I'm not going to rely on LLVM or whatever future backend I might use. I'm going to do that myself, because I really want to guarantee that, or at least not guarantee that it always does it, because you cannot. There are certain heuristics, but at least have more control over it.
I said this in private, but I'm going to say this in public. I'm pretty sure that Yasser can beat LLVM with O2. So Yasser, I hope you do it sometime soon. Within the next 5 years, I hope.
Yeah, I imagine
O2, not O1.
Yeah, I imagine in like I could see myself doing it in like 5 years or 10 years, but like it's definitely going to be a long way before I'm like at that point. I think my current goals right now are get both x86 and ARM working. And so I've recently been redoing some of my code gen stuff to so I had some details of the register allocator that were like stapled to like x86, and I like unstapled those so I could actually deal with like register allocation on both ARM and x86 the same way. And I was like, oh, okay, cool. Once I have that kind of crap done, and then I fix tons of bugs, then I could start pushing for, oh, this is like, O1 competitive. And then from there, like, it's not easy, but it is easier. Yeah, it is easier to work towards O2.
Yeah, I think I suspect at least for a lot of LLVM users, the challenge, at least with these optimization passes, is that, well, one, they are costly sometimes, but two, at least if you go through like the documentation or whatsoever, there is, maybe Matt can correct me, as far as I know, there's no overview of what the cost is of certain passes, how they sort of scale relative to their input. The result is that basically when you say, oh, compile with O2, you have no clue what impact that's going to have. And it also means that if you want to say, figure out, hey, which passes are relevant for my language, instead of this black box where I just flip a switch, as far as I know, the only way to do that is you try them and you basically hope that you observe something. Basically, you hope for the best. But there's nothing where it's like, oh, this pass scales relative to whatever.
Why are you picking your passes? This is like a madness.
No, so it's not so much like I want to pick all individually. I think InterSnuff took a similar approach here where they, if I remember correctly, they basically don't say O1, O2, O3. They have an explicit list of passes that they enable. The idea there is that if let's say you flip O2, and let's say it runs 10 passes, and 2 of those take up the majority of your compilation time. But for your language, for whatever reason, they're just not relevant, right? Ideally, you would say, oh, screw those 2 passes. I don't need them.
Yeah.
But then you need to basically know, which are those passes? How do they scale? Even just measuring the time spent in passes is
it's like the wrong design
difficult.
for compiler.
Well, I would say
that's one of those big things I picked up with. Go ahead.
But in the default LLVM pipeline, you won't have these like obvious bottlenecks. It's pretty flat profile. So
no, right. That's so I right now don't have any. I think the only pass I've enabled is mem to rec because that's basically required to get sort of sane code. Everything else is because there's this problem, like I don't know which ones make sense, and apparently if I just flip O2, it's gonna slow things down dramatically to a point where I don't want to flip O2 basically. So you have to figure that out, but there's no info on this whatsoever.
One of the things I noticed when writing like a C of Nodes compiler. So originally, before I started learning C of Nodes, which was maybe like a little less than a year ago, it was all SSA CFG, and I was originally just going to do what LLVM does, but faster, as in like implementation wise, just smaller data structures and then run faster that way. One of the things I realized is that like the whole passes thing is kind of like the flawed model, because one of the things you end up with is, let's say we have things like GVN, or we have like sparse conditional constant propagation. Those, like, I don't need to run these separately if they are both really fast to run, if they're both like one unified. Like, I am actually okay with just saying, like, if you run the peoples, you're just running all the peoples to completion, and that's it. And like, because it runs quickly, it doesn't really matter as in like, oh, do you want to take one out or one not? Like it. And then the other thing about like, if it's not relevant to your code, well, the peoples are picked based off of what's in your IR. So like, if it scans your IR, doesn't see something that's like relevant to peoples, they're just not going to end up like, working. They're not going to do work because there's nothing for them.
You're not going to rescan everything for no reason.
You don't rescan.
Exactly. Yeah, exactly. You're not paying the huge rescan costs.
The scan itself is basically, I didn't do it for the people that didn't apply. Like I didn't do any work to not apply the people. Like I didn't even look at and say, you don't have an X, so I don't need to do it. That wasn't ever part of the equation either. It's really literally free to have something that's not in there.
I don't know if you guys have any idea how many times people told me that there's no way to produce faster code than what C does, and there's no way to build a better compiler than LLVM. You have no idea how many times people say that to me. I don't even bring up
why are you wasting
and it's unfortunate.
Why are you wasting any mental cycles listening to people who talk like that, though? That just seems ridiculous.
No, I don't listen to them. It's just
because that's gonna like, if you stopped listening to them, it wouldn't take you 3 days to build an OS. It would only take you 2.
There is some truth in what he's saying there, Levo.
No, it's not that I don't. It's not that I'm listening to them. It's just whenever I post my compiler like online, people will leave the comments. It's like, why are you trying to compete
why
with
are you reading comments?
Why do you think you can? Well, I try to answer a couple of them.
But yeah, pay them no never mind, and don't burn any emotional cycles when somebody disses you that way. Just walk away.
And a couple of friends will also say that to me, like when we're talking face to face, like someone will say, "How's the compiler going?" And like, you still think you can do like as much as C++?
Right,
like,
but how many of them have written LLVM? How many of them have written a C compiler? It's okay for people to not know what they're talking about. I mean, I spent most of my life doing that.
I still wonder about like how true 64 if 64K is all you need. Like maybe in that era it might have been true, but that's just a funny
the first HotSpot got record-winning Spectavium 98 numbers on 64 megabyte machines. So
the amazing thing was how much C improved because of HotSpot, C and C++ compilers, because the one that was just unbelievable. I don't know if you remember this, Cliff, but they had some encryption decryption benchmarks, and the C libraries couldn't inline, so it was all virtual, basically all DLL virtual shit. And HotSpot was like, oh, library I've never seen before, sure, I'll inline that at runtime. And and with encryption you have so many tiny little calls getting like, give me a constant again.
Yeah.
So it's like a death by literally a trillion cuts, and HotSpot was like, fuck that.
I don't understand. So it's not inlining the user's code with the encryption code, or is it not inlining within the
You're
encryption
not
module?
understanding because it's all just code. HotSpot doesn't care if it's user code or Java library code or security code. It's like, I'll just inline that. Sure, give it to me. I've never seen it before. I have no idea where it came from. It's small enough. I just start pulling it in, right? Like,
Okay, so I'm assuming this means you're linking, dynamically linking like a
cross an
library.
ABI, it is sucking
Yeah.
in code and
Yes,
inlining
right.
it. And it's
Hotspot.
like, no, I'll just keep calling that over there, through that DLL thunk,
Right.
Yeah, that's one of the
No-
reasons why I wanted to compile speed is because I just want to inline everything, just have everything fast.
So there's no separate compilation in Hotspot. It's all done as a whole program compilation every time.
Did anyone ever ask you how you felt about log2j, or what's that
log4j? Oh,
yeah.
Waste of time that the million lemmings ran off the cliff. They're called log4j. Here's the million and one coming and run off. Okay, fine. I gave up on that one long ago.
Just because it was
that was the
globally
one
synchronized or something better?
No. Whenever I looked at somebody else's use of logging for whatever reason, what I discovered was that somebody wanted to log something so they could debug their problem. So they put a log line that said something to them. Somebody else came along and did that. Now the output of the program contains a bunch of lines from different people that means something to them and to nobody else. And other people can't understand what's in the log. And pretty soon the log grows without bound. And these people get up and leave the company. They're not there anymore. The log never shrank. It only ever spewed shit out that no one left alive could know what it meant or why it was in there. And it was just
that's not a log4j complaint, then. That's just a
logging complaint. Yeah,
logging complaint.
No, it was a logging complaint. Log4j just both made it easy and made it slow. And they fixed some of the slow, but they encouraged people in this whole mindset of, I'm going to solve my problem by printf to a log file that that everyone has to look at. No, it's not my log file; it's everyone's log file. I don't get a printf for me.
Very importantly, log4j also gave every server running it over to whomever wanted to take it over. So
yeah, that's a separate log4j bug. There's not counting security holes or denial of service attacks. There's plenty of denial of service attacks where you're logging your disk bandwidth.
I was asking because of that security problem that affected like everyone. How it like
that was a stupid thing
like...
in log4j, but it was a stupid log4j bug. Had everybody on the planet who ever did anything similar did the same thing. Hey, here's a special character. Now execute the following code as if it's like code and just go execute it. Like, you should be shot. What are you doing? Of course you got a security hole. Fine.
I find it comforting that I finally meet somebody who is saying the same things about logging, as in, fuck most of your logs.
Yeah,
because I really like logging. Because it's, especially in concurrent and distributed applications, it's, especially in production environments, it's just so much more useful than debuggers. Because you throw in a debugger and suddenly your 10,000 users can't access the page anymore because it's now waiting for your breakpoint. But the problem, for example, I consistently ran into at GitLab is people adding logs that are just completely, I'll keep it friendly, they're not useful. In the sense that they were useful when they were building their thing, when they were perhaps debugging their thing. But then, 2 months later, some system administrator comes along and is like, hey, why do we have 10 gigs of logs on this server? And it's because somebody decided to log an entire JSON payload that nobody else ever looks at. And I do have to admit, I do not yet know the proper answer there.
So
because
I have one suggestion to consider, which is, it's not that logging is all useless. It's that it's useless when things are going okay. And so what you really want in a logging framework, and I've seen it once or twice, but basically you want the developers to keep doing all their stupid logs that they never clean out, right? But basically, as long as everything completes okay, you want all of that to never be realized, meaning never even stringified and just thrown away. But if anything goes wrong, it's like, okay, I've got this pile of stuff that I was handed that has everything everything captured. I need to realize it. And now I'm going to go through and I'm going to slowly realize them, expand them into strings, write them to a file, right? But basically you only want that to happen when something goes wrong.
Right.
I never
I
thought of
feel
that.
the ideal sort of logging approach is that, or sort of backtrack. The sort of problems we ran into is like, yes, one, noisy logs that aren't useful. People logging warnings, and I'm of the opinion that warnings should not be like, it's either an error or it doesn't exist. When you're logging a warning, that's like, make up your mind basically, because you end up with a lot of warnings that nobody looks at. It becomes a noise, and then it defeats the purpose. Right.
Linux does that, but I think only for obsolete functions and just to see if it's safe to remove, like in a
Right.
future.
I think for like deprecation warnings, that's a thing.
Yeah,
I
but
think
just
let
do
me
it
rephrase
once.
it. A log
once.
or a warning or whatever, it should be actionable. Like you should be able to look at it and figure, okay, this is what I need to do.
There's
And I would argue 99% of them are not that.
I think there's some takeaways here. I would like to see that you're not allowed to push your logs off to main without a planned depreciation on the log, or to master without a planned depreciation. I'm logging on my desk. That's great. If I push that to master, I get whacked on the knuckles. Unless I go ask permission, and then we have okay, you can run in production for a while. There's a known sunset period, and after the sunset, we're yanking it. One of the things I have had to deal with is people left the company, their logging code remained. No one knew what it did or why it was there. Somebody changed something else, the logging code broke. Now the question is, repair the logging code. Well, who owns it? Well, who cares? Did the fast repairers delete it? Can I delete it? This is a giant open question. Shouldn't have ever come around. It should have been sunsetted before the guy left the company. You're done. We don't need this log. Get it out of here.
The other thing is there's just
I
so much
forget-
repetition in the logs that when you're testing it as a single developer on your local machine, there's almost nothing in the log, right? And then you put it in production and it's like spitting out 100 gigabytes an hour of log, right? Then you move to a SAN and you're filling a SAN with 100 gigabytes of data per hour at a cost of whatever dollars per gigabyte, right? And it never goes away, right? Nobody ever cleans it up, right? And so half your performance is going just to logging.
So I think in theory. Sorry, you go first.
Yeah, so earlier Cliff was saying that no one took up Sea of Nodes, and the few that did really liked it. This reminds me of dev practices. Like I gave up trying to tell anyone any of my dev practices. The only time people actually liked it was when they asked me about it. Like if they don't ask, they're just gonna hate my dev practice no matter how useful it is. I just gave up.
This is a general life rule. If you're trying to say something and the other guy's not asking, he's not listening. And then it doesn't matter what you say.
Like probably like a decade ago, one of my team members, like a coworker, he like I thought like we're all on the same team, we're all working on the same code bases. If I know something, I should probably mention it, and if they want more detail, they can ask me about it. So I would say, oh yeah, that's a closure. You should maybe look it up or whatever. And then he's just like saying, no, you should always use global variables and a bunch of other things, even though I like global variables. It's just that just mentioning things to him, he would just get offended. So it's just like I don't even mention things to my team members, like about things that they can ask me about.
Oh, I would.
That's your story.
But walk away from sort of. I would say there are certain classes of people that it's best for your personal health and well-being to just walk away from. And if you run into those and you red flag them in your head that I'm not going to do this or I don't want to talk that, it's time to, look at your options about where to go next. That this is, spend your life dodging a person. It's not fun. Go.
Oh no, it didn't get to that. It's just I just stopped mentioning anything because he would just be offended that I even brought it up.
Right. I'm just saying after that point, don't count him as a friend, count him as a work acquaintance. It happens. You got an answer worked out, fine.
I wanted to add something to what Yorick said about logging, like logs being actionable. I think like what we do, we also have like this big distributed system, and like it needs to be very reliable. So usually every log, even if it's a warning, has some kind of alert or alert system like associated with it. Like if a set of logs, like if you have a sustained level of warnings, for some event, even if it's like rather trivial or something, like if it doesn't fire off any alert and actually gets a human to look at, then it's basically useless. I mean, if it's like basically it will only be useful for post-mortem debugging, but other than that, really it needs to be collected to alert. So usually in our MRs, we often look like if you introduce like a log for a warning or something, you usually are going to be also adding some kind of alerting, because that's actionable.
You need a git blame for log where it automatically routes all the logs that someone added to their cell phone.
Well, I have a shortcut for git blame on all my terminals.
No, this is for the log output. You wrote this log. Okay, I'm going to choke up your hardware, your phone with this log output until you decide that you actually didn't need that logging.
Or you don't need to repeat it 500,000 times. So just open a Jira entry, assign it to them for each time one of their logs shows up.
Yes.
But I think that the post-mortem debugging is actually, it's a big one. And I'm grateful for it. Like I worked on some of the really bad bugs where just having the logs, maybe even like not directly related, but they just had enough information to actually discover what's going on. So actually, I don't think I share that sentiment towards logs. I like having them for this one bad day where things go south.
I think there's another in-between zone where we can agree that there's a company-wide policy that we want to know about the following state transitions going on in our product, and we're going to maintain this amount of logging so we can track that. But if Cliff Click decides I'm debugging how best to go sort my persons per second widgets or whatever, and I log for that, when I'm done with that project, that log should go away, and that log shouldn't hit production unless there's some good reason it hits production. So I claim a small amount of logging, especially in a distributed system, has some benefit, but the amount of logging I normally see is a million times larger than necessary. It's just outrageously bigger.
I mean, the thing is like if you log excessively, and that can very easily happen, then the storage and infrastructure cost of your logging actually goes up, and it's really expensive, and you can't actually like just store this amount of logging data persistently without your company getting bankrupt. It's actually a really big problem. So
Splunk, there's like a company who makes its living like sorting other people's dead logs.
Yeah, there's a company that definitely, at least at minimum, one company that you just pass in events to, and then their entire business is just displaying it to you, so you can figure out what went wrong. I want to ask both Aaron and Yorick, but since Aaron's not here, I'll just ask Yorick. So when you debug some kind of like problem, I know why a debugger wouldn't make sense, but is there like no way for you to say, I know this specific thing causes a problem, so you can like start a debugger saying execute like this SQL command or this web page, and then let you step through everything? Or is that like basically impossible because everything's distributed?
Let's see how I break that down.
I'll just give a mini example. In my compiler, I log serial IDs, and then I can say, when I hit this ID, give me a breakpoint, and then I could start stepping through things.
Right. So let's say there's sort of two classes of programs. You have the sort of offline ones, a compiler, grep, these kind of command line tools that run on your computer and basically your computer alone. And then you have the more distributed ones, like your average web application, a DNS server, that sort of thing. Basically, the kind of application where you are not the only person using it. In that first case, you can basically use whatever you want, debuggers, printf, whatever, because it doesn't affect anybody. But if, say, let's take an example at GitLab, we had, I think, around the time I left, I think we had something like 20 application servers. Each ran, I think it was about 16 processes handling web requests, maybe more, but let's say a dozen or so per server. The first problem there is if some error occurs, you have to figure out which server it is, and chances are it's not really tied to the server. Then if you want to run a debugger on it, ignoring the debuggers in Ruby are terrible, but let's imagine we have a language where the tooling is great.
Are most of the problems dealing with distribution and not like the actual code itself? Because that's like a whole class of things.
It's largely the fact that if I want to debug why this particular user keeps running into this particular problem, right, like a crash or whatever, if I attach a debugger to some process, it typically pauses the entire process. I'm pretty sure there's debuggers that can only do it per thread, but either way, there's some form of interruption going on. If, depending on your scale, that may mean, I don't know, 10,000 users are suddenly experiencing their page hanging until whatever load balancing system you have kicks in. It's like, hey, wait a minute, this thing is no longer responding. And we had that. I mean, I built it. But it would, I think, still take up to 30 seconds for it to catch up, just to account for sporadic, slower things and whatnot. Like it had to evaluate some statistics before it said, okay, clearly the server is not responding anymore. And so if you do that frequently, people are going to complain like, hey, why on a frequent basis is this stuff not working? And then people would say, well, because our developers are trying to debug stuff.
I can't believe that you've run a debugger in production.
No, I haven't, precisely
Okay.
because of that. Because
Yes.
this is like, no, right? It's a different story. Like if you have a small service and it's still in beta and you have like 100 users, like yeah, whatever, it doesn't matter. But GitLab, we had, I think at peak, I don't know, like 500,000 requests per minute or something around the time I left. So anything that pauses a process for somebody to look at, like instantly alerts go off, people get paged, all sorts of things. So that immediately means you cannot really do interactive debugging, whether it's an actual debugger or something else. So you have to do logging, tracing, all these other things. And that's where you run this problem where you end up with a lot of noise.
So if one specific user gets a problem on one page, is it very hard to reproduce the problem in Sandbox?
That very much depends on the problem. So
is that typical? I mean,
so in case, for example, of like GitLab, a lot of the problems we ran into, well, I would say there's sort of three classes of problems we ran into. They were problems sort of caused by, and I have to be careful because I'm technically still under NDA until the end of this year, but I would say problems caused by lack of time, where because of management decisions or developers perhaps living up, there was not enough time to do things properly. So you run into basically stupid issues where you're like, oh, why are we doing this, right? In case of GitLab, it's very network driven. Like it would call out to a lot of other services. And so a lot of errors were actually just network timeouts where, somebody, they pushed a commit and it would trigger a call to Jira to create an issue, but the call timed out, for example. So now you have to go in and figure out, okay, why did that happen? And then you have like performance issues and a bunch of other stuff.
It sounds like Chaos Monkey would help you guys a lot. But I assume you guys used it.
I can go on for hours about this, but the point is basically some of these problems are reasonably straightforward to debug. Right? If it's a timeout, actually triggering that might be difficult, but you can reason about it. You can see, okay, this is the code. We know the timeout is 30 seconds. Clearly we exceeded that, so let's figure out how we can sort of maybe increase it, avoid it, etc. But there were also difficult issues such as we had a database load balancing system where writes go through the primary and then reads go to like a bunch of secondaries. And then there was this system where if you perform a write, then after that reads go to the primary until that's figured out, hey, that write is now available across all secondaries again. Mm-hmm. And the whole point behind that was so that if I create an issue and it reloads the page to show it, I don't get a 404 because I hit a database that does not yet have the data. Mm-hmm. Getting that to work reliably was quite tricky because you end up in these cases where, let's say 8 out of 10 times it works fine. 2 out of 10 times you get a 404. You try to reproduce it, doesn't happen, right? Because it's very timing sensitive, or maybe their data was like 2 bytes too large, so now it's replicated at a slightly different rate, right? That's where
it sounds right.
That's where I really say I don't know the exact solution to this problem, because you can log the absolute shit out of it, but you get a lot of noise and it loses its value. You can do logs at sort of boundaries, like at the start and end of transactions, for example. But it's
my main
typically
question was how easy would it be to reproduce? But it sounds like everything could go wrong. So
it depends. That's the answer. Right.
I have a similar H2O related thing. It was much the same kind of problems. We ended up with a local ring buffer log that was fixed in size, in memory only, super cheap, so it wasn't ever blocking, and it only recorded the last 1,000 or 10,000 events. And every process kept their own on an issue that would, for us, was mostly crash, but you could trigger it off of a timeout or anything. You'd gather the logs from all the machines and write them somewhere, and somebody later would look at the logs, interleave the timestamps. And because we were doing, nanosecond scale interactions between shit, there was other happens before relationships. We would come up with a sorted list of this is what happened when and where, but only basically on request. So the logs were available all the time at low cost because they were just write a timestamp in a buffer, literally a nanoscale timestamp and a token tag and maybe a word of data and a large ring buffer, and you could get it later on demand.
Yeah, that's, I think, a nice sort of hook into that is the issue with logging, like at GitLab at least, we never quite figured it out. I think it's one of those things where a lot of people sort of consider it low-hanging fruit. And I, even though I was heavily involved in performance stuff, I had basically bigger fights to pick.
Mm-hmm.
But one sort of related thing to that is we also had feature flags, and it's very similar to logs, so people add feature flags and then they forget about it. And 2 years later, like, why is this still a feature flag? This has been stable for forever. There we ended up with this system where I don't quite remember how it exactly worked, but if you added a feature flag, it required a YAML file to exist in a certain place, and that then had to list, the author, a link to the issue, and some other info. And if that wasn't there, it would just explode. It would just be like, no, we're not letting you do this. And I vaguely recall we had some processes where if those issues exist, they have to be solved in this much time, basically to prevent this proliferation of feature flags.
HotSpot go bazillion flags. Yes.
The fun thing is that system adds a cost, right? So if you do this at a too specific granularity, you will likely run into the case where the check, hey, is this flag enabled, or should we log data, or should I enable tracing, whatever, that actually ends up outweighing the cost, or at least contributing significantly to it. So much in fact that in I think it was some of the first 2 years, we had no tools for like performance optimizations whatsoever. I built them. And through that, at least one of the things I wanted to figure out is like, hey, we have these issues where we run out of memory. We don't know from where. So we had this tool that would sort of track memory allocations about as efficient as you can do it in Ruby. And the existing tools, they were just horrible in that sense. But that still added a rather significant cost at every request. I don't remember the exact numbers, but it was significant enough that it was only enabled in development, and only you had to like explicitly flip a flag for it.
Yeah.
Because even though it was intended to be able to run in production, the cost was just too significant to run this hook every object that you allocate, because that happens a lot in Ruby. And we had similar cases where I found that all the performance monitoring that we do, I think it added, I don't know, let's say 50 milliseconds of load time to every page, which if it takes 5 seconds, not a big deal. But if you go through the effort of optimizing it to the point where now it takes, let's say, a second in total, that 50, 100, whatever milliseconds, it starts to add up.
Yeah.
You can't disable that because that means you have no data at all. So I think in theory, the ideal solution you would have there at the language level, going back to actual programming languages, is some sort of magical line of code that by default it exists in the binary, but it has no cost whatsoever. And then you flip some magical flag, and suddenly these lines of code become active. And you can, in theory, do this with JIT compilation. We essentially recompile it, because then you don't have this problem where traditionally, if you say restart your application to enable your logging, chances are it won't reproduce the problem anymore. Because now I know traffic is going somewhere else, or now the timings are like slightly different, so it doesn't trigger it.
That was our logging for H2O. We beat it down to about 10 clock cycles, a nanotime, which is an RTC read, and a write of that. And you handed me a logging flag and another pile of bits, which we smushed and stored, and you checked the ring buffer for wrapping. So I'm gonna claim around 10 clocks. And that was so cheap that it wasn't killing anybody. It wasn't changing the timing. So we left it on all the time. But we worked hard to beat it down to that low cost so that we could leave it on all the time and not have it kill us.
I'm not sure what I did, but I think I had a read timestamp in one of my hot loops, and it completely destroyed the performance. And I thought it was like so cheap that it was like 36 cycles. So I didn't know why it would ruin the performance, but
well, the standard Linux get time of day read reads a bunch of things and writes them out and reads them a second time and confirms that nothing changed. It reads 36 bytes or something, 48, 64 bytes, and then it reads it again and confirms nothing changed. Then he takes those and does some add, subtract, multiply, divide crap to come up with the time of day. So on the order of 36 clocks.
CPU instruction, 36 cycles, not time of day.
For a read clock? Read RDST.
Read
that's varied over time, but has not been generally cheaper. I don't know what it is today.
I think today it's somewhere around 20 or 30 cycles, and it clogs up the pipeline for some reason. I don't quite know what.
On an x86 or an AMD?
On Intel, it used to be
x86.
cheaper.
I don't know what it
They
is on
slowed
AMD.
it down because it was used for security hacks. That's why AMD slowed it down.
Right.
That's annoying.
And at the time, Intel hadn't. I don't know if they have now or not. Matt would know.
They slowed the call, or they lowered the resolution?
They slowed the call. They added like,
awesome.
I don't know. Like it was recently it was like 21 cycles on AMD.
All right.
Yeah, well, it's 36 on my Zen.
I remember the resolution was something about 36 cycles on AMD, but there is another counter that you can use to override this. I posted this a long time ago on Discord. There's been a bunch of papers about that.
Okay, but I was just surprised because I don't remember reading about it being like it being a synchronizing function or intrinsic. So I was just surprised about it.
Is it also synchronizing? I mean, blocking or whatever, memory order.
I don't think so, because people recommend using some other function right before it. Maybe get CPU or get.
Okay. Yeah, I don't like for the test case where I'm logging for debugging purposes. I don't need it to be synchronous. I want it to have low throughput, latent throughput costs, and latency can be bad, but not block any other dispatch.
I think I was trying to measure how fast, like the slowest and the fastest case for my hot loop, but it just made it so much more slower that like the numbers was just garbage.
Is this just
it's twice as slow.
Read the register and throw the result away, and
it was basically read the register, add it to one number, subtract it from another number, and then I would just like have a log of it.
Yeah, so the log could be the cost.
Or it would have been or maybe I just did the min and max of like the numbers, like read the last value and then
right, do a little math. Okay, so if you do a little math and a hot loop, it's all in registers. I'm trying to verify you're not killing yourself by writing a log that's continuously streaming, because that will blow you out. That has nothing to do with
logging
costs.
Yeah, no, I must have done the min and max, but I do remember that the loop happened like millions of times, and it slowed it. It made it twice as slow. So I think
Right.
maybe it just blew out the rest
Well, see if you can find some more reasonable benchmarky situation. Hot loop that's tight is good. Throw this thing in or out and see if you can get the latency for it. Because I'm kind of curious what the throughput is on it. Because you have a loop that made it twice as slow, but you know, you could have really cheap loops. So twice as slow as what is not a good measurement. Fine.
I really want to do more distributed and microservice kind of stuff, but you know,
you got your hands full with your memory safety and your OS and your debugger.
well, it's also that how many users do I have? I don't have enough users to stress test like a single server.
It does help to have users to just drive the need in your head.
Yeah, and I'm definitely not going to have users with my text editor because I don't want my text editor to connect to the internet.
Well, mine doesn't connect to the internet unless I ask it to. So fine.
So, Adrian, were you preparing for something?
I can show something. Yeah, I can show some things now.
Okay, I'm just gonna finish my thoughts.
Sure.
I really want to do more distributed stuff because what I did for because I said this a few times on Discord is just I don't want threads, or at least not threads the way people do things. I want to make things that you can. It is very deterministic. So like reading a file or a socket, I have it like right now. My code basically you basically say how many bytes you want, and it would either be false or like true or false. And I guess the loop, like the loop is not deterministic, but for the most part it is. So it's very hard to get bugs because you misread things, because you're never going to have like half of like what you're expecting. You're always going to have the number that you're expecting. You could only access that. But anyway, I'll show a good demo like one day, hopefully soon. But yeah, that's
love to
the
see
end of
it.
my thought.
In terms of determinism stuff, because I do like multi-threading stuff sometimes, my guarantees are basically do with like binaries being the same. So like if you run with the exact same conditions, like if I run once and then I run immediately afterwards, nothing's changed. It should give me the same kind of binary. If I run it a day after and I haven't changed anything, it should give me the same binary. And then the way that I guarantee that is I literally just tag everything with like ordinals, so then I can sort them later. And that's
Yeah,
like
I made a
solves most of my problems, because a lot of compiler work is like surprisingly parallel, like embarrassingly
Yeah, I
parallel.
made a mistake because I in one case when I tested with the large file, it would do a relock, and then that broke my system because it thought that relocks was impossible after a certain point. So yeah.
So Yasser,
Yeah.
I'm gonna have to slap you a little for your comment, because there's two different topics here. You're talking about multi-threaded compilers, and Levo hasn't figured out to do threads at all in his language yet. So those are kind of two different things.
My compiler does threads. The language, I'm allergic with that. Like I do not want threads in mine.
Yeah, threads are good enough for
the
Levo,
only
but not
the
for
only
anyone
real
else.
project I should be focusing on is my compiler, which is the thing I'm talking about in relation to writing threaded code. And then the idea is like my guarantees are around like binary compat, or like
what
binary
language are you writing threaded code in?
I'm running it in C, which is not fun, but like a lot of it boils down to because it's compiler work. To be fair, a lot of it is a very embarrassing parallel.
When you say
work.
threaded, when you say
Is it?
threaded, do you mean multi-threaded or threaded as in threaded interpreter? Because you're also writing
no,
an
no,
interpreter,
oh,
right?
Yeah, sorry, multi-threaded code.
Okay,
like
okay.
as in
Yeah,
I've got like some giant like thread pool, and I say, oh, go do some work over there.
All right, Adrian, do it.
Right, yeah, I can share some stuff. All right. Can you see my terminal?
Yeah, I see it.
I see everything great.
Great, nice. So basically, right, it's pretty. I can show some pretty C-like stuff. So this is like a function bar, and it takes in, well, let's say it just takes in a parameter count and returns the like that multiplied by itself. And I'm gonna move the camera.
Just a question: is this Cliff's? Is this code for Cliff's challenge, or is this just like a tutorial kind of code?
Yes. This code is I'm writing it for Cliff's challenge, and I noticed like some weird things. For instance, that I was able to get the like user space like time quite low, and then I realized that I'm spending way too much in the kernel. But I actually copied your C++ code, so I'm doing fread, which I don't think is
good.
it's not ideal. I think mmap should be faster, but anyways, like I'm doing fread, I'm doing the same, like using the same buffer sizes, and for some reason I'm spending like 5 times as much in the kernel. I don't know. I need to profile this, but
5 times compared to my code.
Yes. I don't know. I'll figure it out. It doesn't matter. Like for now, I'm anyways mostly interested in getting like good SIMD code generation. Yeah, so I can go through this. This is like a very normal function. I can compile this, and then here I'm just dumping it out and just here multiplying and returning. So this is basically that there are no SIMD semantics like going on here, but like here the things are a bit different. So there's this term uniform, which is similar to OpenCL. The idea is that this function foo gets you can call it normally from your C or C++ code, it has a C calling convention. But once you run it, the idea is that uniform, basically the program is written in a sequential way, but it is actually executed once for every like a SIMD lane. So let's say you're on an ARM.
It allows parallel execution within elements in each array.
Yes.
The arrays are aligned and the count is the same for both. There's a bunch of rules you'd apply here is what I'm hearing you say.
Well, yes. So this for each loop is rather magic because it actually takes care of loop peeling. It takes care of alignment. So it actually generates
Well, it does
lots
handle
of
alignment. Like you're not even required to pass an aligned left-hand side.
I think yes, there's aliasing restrictions similar to Fortran, so they can't overlap. But alignment, I think, yeah, I think they're like they're not that strict rules. Yeah, this is like you can see like this function here, like this is the code that generates here on the right. So
there's a bunch of and threes at the top. That's alignment.
Yeah, and
go well, fine. Just scroll on by.
Sorry, yeah, basically lots of versions of this loop, but yeah.
Yeah, find a good back branch. 0fc. So B24 line goes to foo plus 0xfc. So scroll out, find 0xfc here.
Honestly, I have no idea what this code does.
Okay, I was going to find your hot inner loop and then declare. So I can believe you have alignment going on in the generated code. That's fine. Makes sense.
Yeah, so the thing is like basically this language has this for each construct, and then on the other side you have also like some other things, but generally there's this one thing again. So when you declare a variable like this integer sum, what you're doing is you're declaring a varying variable. So you can't return this variable from this like function because it is different, or it can be different from every like for every SIMD lane or for every parallel thread of execution.
Lanes. Yeah, okay. And
so
then you
the idea, yes, the idea is that you can declare like variables, you can manipulate them differently in these different contexts, and then you need to have some kind of reduction, and that's how you basically how you traverse, like how you convert between uniform and varying values. So this lets you like write something interesting stuff. So for instance, in this loop, I was hoping to skip through my data until I find a new line, which is ASCII code 10.
So you could put a quote /n quote, and then it didn't have to have the number.
Yeah, it has no support for that, unfortunately.
Oh, it's the language. Oh, right. Fine.
Yeah, this is
with macros. It's a language.
Yeah, it's a proper language. Yeah, and so basically, like what you're doing here is you have this Boolean found. I'm trying to find a new line. So I go into this loop,
so you have
and then
you have a bit array found. Okay.
Yeah, actually, basically right. Is a bit a bit array found. Yeah.
The thing is because well, SIMD like SIMD ISAs usually like their lanes are usually at least 8 bits wide. So this is not going to be a bit array in the end. And but what I'm doing here is like assigning to found the just a comparison at a certain index, and this index is a varying value. It's basically like thread index in CUDA, so it refers to the actual index of the program instance. So there are these different programs.
It's kind of the lane.
Yes, that's the lane, like lane number. And then after I compute this, I reduce it here, and this is my like break condition for the loop.
Right. That's the test for all bits 0 or whatever.
Yeah.
Right. Exactly.
I just don't understand the found, because the data looks like it's like a SIMD like an array.
Yeah.
So is found saying that it's a bool for
Found is an array.
elements?
Levo, found is an array.
Yeah.
The thing is,
okay, because I see bool found at the very
but you can't believe that because it's SIMD. That's the uniform thing.
Okay.
It's an array of bits for each SIMD lane.
Okay, then that's why this is any. So it's not like an index. It's actually an array. Okay.
Yes. So it's very interesting actually. So you can put print statements here, and I can't run this right now, so because it will all segfault. But if I put a print statement here and then I just print like something like this, like found, then in the output you will see false, 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 because I have a SIMD count, lane count of 4, and each like lane produces this false value at that point. And then, at its reduction, that's where the program becomes, again, like converges. And it's kind of nice. It does work decently, but there's some problems. And that is that, first of all, this language is kind of mostly geared towards 32-bit integers.
What language is this? Is this yours or some?
No, this is not mine. This is Intel's language, ispc.
It's in the link and in the docs.
Yeah. And I don't know. I think so this, basically, I was thinking about this language a lot because, like, I don't know, in the Discord, we've been criticizing many languages for not exploiting parallelism to a good enough degree. And I mean, there's functional programming and things like Futhark, but there's also like imperative approaches that try to make the situation better. So I was very curious how good.
You're explicitly declaring parallel on a small scale. When
kind
you
of,
say
yeah.
uniform.
Yeah. Uniform. Uniform means that this value is the same for every SIMD lane. So.
Yeah.
Right. Yeah. Exactly. I mean, but it's a lot easier. You don't have to write any intrinsics, and hopefully the code is good. But it turns out that, like, first of all, this lane count, it's kind of fixed, and it's a compilation flag, and this means that well, I have a lane count of 4 when I compile this on my ARM system, like a Apple M1 system, and that means that it's not actually utilizing every possible SIMD lane, because if I'm like if I'm traversing through a byte stream, then I should ideally have 16 lanes of 8-bit, like of 8-bit size, but that's not what I'm getting here. And then the actual assembly output is also pretty bad. So I can show two comparisons.
Wait. Did I just hear what you said was Intel made this slow on M1 on purpose? And does it limit it to 2 for AMD, hopefully?
I don't know about on purpose.
Sorry,
I assume good faith.
Intel is constantly cheating. Intel is constantly cheating on benchmarks.
I've dealt with Intel compilers that were clearly not operating in good faith.
Yeah,
but it was a long time ago. I was working at Motorola on PowerPC chips, and we were competing against Intel, and Intel was cheating on benchmarks, and we called them out quietly, and they quietly fixed their got caught bug.
All right. Yeah, I can't actually. Okay, so I need to find I will try to find a good example later at some point, like maybe next CCC, and yeah,
this is kind of a fun, but it was good to see somebody's attempt at a language that says explicit SIMD, and you can talk about the variables per loop iteration.
Yeah,
that's running in parallel.
Yeah, like there's some really cool stuff. Like first of all, like one big problem with languages that are like go heavy into the GPU style is that, well, you need a I mean, you need a driver, you need a way to like compile this kernel and like give it as a payload. Like there's a lot of ceremony around like writing like OpenCL stuff, and it's quite complex. But this because a SIMD parallel language is something you can just call from, and you don't need multi-threading. You can do it on a single core. There's no context switch, so that already simplifies it so much that you can actually integrate it in many like normal or non-ambitious systems programming languages. Yeah, but by the way, I would just like to point out, so what happens if you don't like use the correct mask or a gang size? Like it's the number of lane counts, they're also referred to as the gang size in this language. And what happens is that you get something, this is in the comment is pretty great. So you're loading the first like byte into this position of this whole SIMD vector in one position here, one position here. But there are lots of zeros here. So you're just using like 25% of the whole of the whole vector. And so you need to take care of compiling with the right flags, and on ARM, sometimes there are some problems like vectorizing these loops. So it still feels like you're a bit in the LLVM auto-vectorizer land where things are kind of fragile. And I haven't figured out how to like make everything work perfectly. So yeah, but I think there's some cool ideas here because the language is kind of simple and you get these magic for each loops. And yeah, again, like I like a lot how easy it is to call and link to it. Like this is the C++ function here. And I'm just like creating mallocing a buffer, then calling this like yeah, this auto-generated header function, and then I look into here and I see this. So yeah.
Have you got any performance numbers?
Yeah, so I'm getting actually like quite close to I'm getting like I can probably traverse this like entire trading data in like less than 1 second. Whereas Levo's numbers are like 780 milliseconds. So it's still better for sure, but I can see where the problem is. So the code generation is in some places abysmal, but I also have to understand how to work the language.
Right.
Because by the way, I did one of the like super cursed things. I guess I can. I guess it already would work here. Here, all right. So. Basically here you have, here I'm setting this found variable, like this Boolean, I'm setting it to data at this index equals 10. The funny thing is, if I say if whatever data equals 10, found equals true and else equals false or something, or just don't have this else, whatever. Yeah. I mean, the programs are equivalent, but I'm generating like twice as much code and it performs super horribly. So I'm like, the performance just halves right there.
It is fragile, as you said. It's like vectorizing. Right. It's a little fragile.
Yeah.
Okay.
And I was kind of maybe I was a bit like too accustomed to LLVM removing my horrible trivial control flow that I put somewhere there. Yeah. So definitely some things that look trivial are definitely not zero cost here. So you have to be careful. Yeah.
Interesting.
But I'm not giving up. I really want to avoid writing any type of assembly yet, because I want to see how far I can push it. Because once you have this program, it compiles
you removed the conditional, so it was able to merge the two conceptual branches.
Yeah, right. You got right. It's like using a C move or something.
Yeah,
because the compiler doesn't know, or it doesn't communicate what any does.
No. One can be treated as no control flow and one has control flow, definitely. And if the compiler removed the one control flow and turned it into a conditional move or a Boolean turn you to a Boolean directly, then he has a loop with no control flow and that enables a bunch of other things. So C2 does the same kind of behavior for the same kind of reason. He will yank your funny control flow. That's good. I mean, he'll do. He's not doing the SIMD thing. Well, he is, but not directly here. But for the same reason, I understand that there's another step to the compiler that has to happen to get the next level of optimization where you yank the dumb control flow and then not care about it. This is not it doesn't come for free, if you will.
Well, you can still
try to figure that like. Go ahead.
No, you first.
Oh, I was just gonna say something dumb, which is I always figured that like compilers were like ships or cars, where like they were she's, but you've been referring to C2 as like a he, which is kind of funny to me.
I don't know. When
Yeah.
did C2 become a he versus a she? Because I was in a fight with C2. C2 was in a fight forever and a day.
Why not it? I mean, I'm not a native English speaker.
Because I don't put its on anything except like tables and chairs and something complicated I poured love into gets a
Yeah, no, I
gender.
definitely like personify things, but yeah, there's usually usually in English when people talk about things like cars or ships and stuff, like they usually describe those as she's.
Yeah.
Yeah, I noticed this. I was really into in the guitar community, and there people always refer to their beloved Gibsons as like a she. And the thing is, I mean, guitars make sounds, so they would say how much their guitar squeals, you know, like she squeals
You're walking
or
dangerous
something.
ground here, dude.
No, I'm just saying it sounds a bit weird, but you know, I think yeah.
Weirdos.
Open mouth.
I never do any of that.
All right. On that note, I'm going to look to wind down. Anyone want to add any last minute comments here?
Yeah,
I was
I
just
got
gonna
my
say-
first running version of the Sea of Nodes interpreter.
You have something running.
Yeah.
Oh shit, dude. That's exciting. And also we're right at noon.
Yeah.
All right.
I mean, I don't have a cool demo, so I would not.
short
I would
demo.
not show it. Oh, I could show it though.
Yeah, short demo because I'm very interested. I never
So-
did one, and I'm curious to see how it goes.
The thing I was gonna say was you can subtract the conditional if it's a bool with 0, and then that would get you an all negative bit mask, and then you can
There is
use
a
that to figure
transformation.
out.
There is a transformation, Lebo, that converts control flow into a Boolean flag set. But the compiler has to recognize that he needs to do it, and he does it. Now he has no control flow in the loop. Bunch more new operations apply after.
I would imagine it's super simple for the case that Adrian showed, and I don't know why it's not implemented, but it could just
Write an optimizer and find out.
By the
yeah,
way,
maybe they just didn't put the effort.
Okay,
or,
I'm
I mean,
gonna let the
didn't have
Yasser
time.
do his thing.
All right, so quick demo. We've got my Sea of Nodes stuff, which does not show up as a fancy graph-viz graph. It instead shows up in this flattened form, and essentially, I can step through it. And so if I step through it here, let's pop this aside.
Let's see. Can you show the output per node in the next to each other somehow?
I don't have a dump right now, but I can technically read them from the in-memory structure.
Okay.
It's like this is where our find node is. It's not initialized yet, but this is right here. And so essentially, once I make some steps, so step 1 is just like gonna set this 1 over to the find node. So now we're I is equal to 1, which is good. And then we keep stepping. Oh, I forgot that I clicked onto the terminal. 7 is over here. That's a region. V14 is the branch itself. I should probably tag those with like the number so it actually knows. V15 is the projection that's down here, which is just the branches. And then, because we did V15, that will do this nasty work, which is basically if it updates a find node, everything that's dependent on the find node will get invalidated so that it gets reevaluated, which means that if something is not that means you can technically have loop invariance by just having something that is like not dependent on the find node. It will not get dirtied here, and everything that gets dirtied is going to get reevaluated. And so, and as we go, we get a higher value on this, like a loop iterator. We're at 4 now,
creeping up. Yeah.
And then it reaches 10, and in which case meets the conditions over here where it's no longer less than 10.
Yeah.
And it
should run off here in a second.
There we go.
Yeah.
End. Yeah.
All right.
Yeah, very shitty. But yeah, we got like the very shitty setup that like checks whatever edge you came from to see what its users were to like sort of do like anti-dependencies.
Mm-hmm.
Yeah, but it's like really messy right now because I think it would fail on certain cases in terms of like discovering all the like dependencies.
Right. I was thinking. Well, you said a bunch of things in there, including you have dirty bits on flags, on fees and stuff. And my mental model, the breadth first search thing, doesn't need a dirty flag, but it could be it might help with optimizations, but it's not. That's not the straight up linear semantics that I had in mind, and then I don't know how all that plays with your other operations.
Yeah,
I claim
I'll
it
have to
looks like a
definitely
good
check on that.
start.
What is it?
I said it looks like a good start, though.
Yeah, this is a first iteration. You know, model
Yeah.
Mark 1.
Mark 1. Yeah, I get it. I get it.
Yeah.
You'll
All
run
right.
into your I didn't quite think the story out situation soon enough. So your types here are done with a byte flag. It says push to
Sorry,
a
which
Java
thing?
class. This is C code. Oh, it's not C++. It's just C code. Yeah. Okay.
These things?
No, on the left, on line number 1088, IB arrow type is unequal to TB region. Line 1088.
Yeah, these are the these are like the tags
Yep.
on the nodes.
Right. And I have virtual calls because I'm Java, or when I did it in C, it was C++. C++ had virtuals. Fine.
Yeah, basically like have so mine are represented in memory as there's like a little tagged header piece, and then there's an additional chunk that gets appended on that's like node specific. So it'll be like,
Right.
oh, if the region, it'll get a
Where
bit
do
of
you put
extra
your
data.
edges? Input count.
That's all in like the header.
Inputs.
So.
I see. Okay, yeah. I mean, that's actually very close to what I had in C2.
Yeah, this is basically the setup. I do like a linked list for the users, which I'm considering dropping because in practice I get two cases. There's like really huge like user lists, and there's like really tiny ones.
Yes. So the C2 optimization, he put the inputs at the end with an extendable C struct that had the edges for the inputs. He had an offset to the start of the outputs, but I had a special case for the one output case. You had one, there was some shortcut I took. And then if you had, two or more, I had a variable array that you indexed off to the end of, and it had slop, so I could add and subtract with, constant time or whatever, amortized constant time to add edges. Because you either had one user or you had a bajillion.
Yeah.
There was some exponential distribution there. All right, I'm gonna.
Yeah, instead of doing one of the annoying bits is I don't do like nice resizing stuff, so I don't have like a cap, and instead I literally just copy it every single time it adds one, which is very slow. But in practice, I usually get I only need to append when I'm doing like regions usually.
Okay.
And
the other one is the inputs for call instructions, which maybe you haven't done yet. We'll have.
I've got calls, but I insert them all at once. Oops.
Okay. And they're fixed, of course. So maybe you don't need any variant input, but it's not a one.
Exactly. It's very bad with like the variable case, but if I have like a fixed thing, then it's fine.
Yeah, fine. All right. I still want to declare victory, although I'd love to, have another go at this. So maybe next week you can show the new and improved version.
Yeah, we'll see Mark 2 in a week's time.
In a week. All right. Anything else? I'm gonna end your share. There you go. Yep. All right. Till we meet again next week. Bye-bye.
See you guys.
See ya.
Good meeting.